Hello students, so far we have discussed differentiability. Today we are going to start differentiation. In first, we will discuss first principle method. Okay, listen, what is that? See, if you want to find f dash x, then it will be limit h tends to 0 f of x plus h minus fx upon h. This method of differentiation is called first principle method, or it is also called ab initio method. Ab initio method, or there is one more name, it is also called delta method. Okay, using this we'll prove all the formulas of differentiation. We can prove. Okay, see. So, first of all, let's prove some formulas. Limit, let's say we want to find the differentiation of sin x. What is sin x? Differentiation of sin x. So, let fx is equals to sin x. Then f dash x is equals to limit h tends to 0. Now, sin of x plus h minus sin x upon h. Okay. Now, can I apply sin c minus sin d over here? Sin c minus sin d. That is 2 cos 2x plus h by 2 into sin h by 2 upon h. Fine? Now, limit h tends to 0 cos of 2x plus h by 2 into sin h by 2 upon h by 2. As we all know that this limit will be 1. If I put h tends to 0 here, I will get cos x. So, is equals to cos x. So, we should remember a formula, or we although remember that the differentiation of sin x is cos x. Okay. Now, let's take one more example. Let's say fx is x square. Let's say fx is x square. Fine. Now, f dash x is equals to limit h tends to 0 x plus h whole square minus x square upon h. Now, is equals to limit h tends to 0. Now here, a square minus b square. What will I get? H into 2x plus h upon h. H cancel. If I apply limit h tends to 0, then we'll get 2x. So, differentiation of x square is 2x. Fine? Okay. Next, let's take one more example. Limit e raised to power x. Now, limit h tends to 0 e raised to power x plus h minus e raised to power x upon h. So, limit h tends to 0 e raised to power x into e raised to power h minus e raised to power x upon h. So, is equals to limit h tends to 0, take e raised to power x common, what you get? E raised to power h minus 1 upon h. Now, we remember that this limit is equal to 1. So, what remain is 1 into e raised to power x. So, answer e raised to power x. Okay. Similarly, you can prove all the formulas, or you can find differentiation of any function. This method is called first principle method. Okay. Now, next heading should be theorems of differentiation. Theorems of differentiation. These are some basic rules for differentiation. Like we have two functions in addition or in subtraction as well. So d by dx of fx plus minus gx. Okay, that is, then it will be d by dx of fx plus minus d by dx of gx. Okay. Second one, d by dx of kfx, where k is any constant, any scalar quantity. So is equals to k d by dx of fx, where k is a scalar. Fine. Next, d by dx of fx into gx. Okay, this is also known as product rule. Okay, so in this, what we are going to do, let's say this is first function and this is second function. Then what we are going to do, we'll differentiate the first. So fx, differentiation of fx will be f dash x. Okay, into second function, it will remain as it is, gx. Plus, now first function will remain as it is and into differentiation of second function. So into fx into g dash x. Fine? Okay. Fourth one, this is called product rule. D by dx of fx upon gx. D by dx of fx upon gx. In this, denominator whole square, gx whole square. This is also known as quotient rule, gx whole square. In numerator, you should write f dash x into gx minus fx into g dash x. So again, it is u by v. Let's say u by v. So what we are going to do, v square, then differentiation of u, v as it is, minus u as it is into differentiation of v. This is also called quotient rule. Okay. You can prove this all theorems using first principle method. Okay. Now let's see. Now today we'll discuss methods of differentiation. Okay. There are different approaches for different kind of functions. Okay. So first method is using right now using standard formulas. In this we are going to do nothing but we'll use standard formulas as name implies. Okay. So right now find dy by dx. If first question is y is equals to x square plus sine inverse x plus log x. Y is equals to x square plus sine inverse x plus log x. As we can see that this is addition. So dy by dx directly. Differentiation of x square 2x. Sine inverse x, all of us knows it is 1 upon under root 1 minus x square. Plus log x. Differentiation of log x is 1 by x. So this is as simple. Okay. Now second question, please write down y is equals to x plus 1 upon x minus 1. Okay. Now here I will apply quotient rule. So dy by dx is equals to denominator whole square. So I'll get x minus 1 whole square. Okay. Now in the numerator I differentiate x plus 1, that is 1, into x minus 1 as it is, minus x plus 1 as it is. Now here I differentiate x minus 1, that is 1. So I am going to get minus 2 upon x minus 1 whole square. Okay. Next, please note down one more question. Y is equals to log x by x plus e raised to power x sin x plus log x base 5. Let's say this is the question. Okay. So dy by dx is equals to, in this I'll apply quotient rule, log x by x. So upon x square. In the numerator, what should I write? Differentiation of log x, that is 1 by x into x, minus log x as it is into differentiation of x, that is 1. Fine? Plus, here I should apply the product rule. So e raised to power x sin x plus e raised to power x cos x plus, now differentiation of log x base a. If the base is e, then answer is 1 by x. If base is a, then answer should be 1 by x into 1 by log 5. Obviously base should be e. Okay, here x's cancel, I get 1 minus log x. Fine? Okay. Next, one more question we are going to do. Please note down. Y is equals to x to the power 4 minus x square plus 1 upon x square plus x plus 1. Fine. What you are going to do? Quotient rule? Yes. But I'll tell you one thing that I told you before also in the chapter of functions, that whenever there is a rational function, do remember, whether it is in anywhere, whether it is in monotony or in indefinite integration or in differentiation or in function, do remember that whenever we have a rational function means polynomial upon polynomial. Okay, then first you should check that the degree of numerator should be less than the denominator. If it is greater than or equal to, degree is, the numerator's degree is greater than or equal to denominator, then first you should divide. Okay, so here first I will divide it. Okay, so y is equals to, can I write this as x square plus 1 whole square minus x square upon x square plus x plus 1. So y is equals to, here I am applying a plus b into a minus b. Fine. So this will get cancelled. What remains is y is equals to x square minus x plus 1. So I have simplified the function before differentiating. Although what I can do is I can differentiate first and then simplify. But that will be a hard task to do. So here dy by dx is equals to 2x minus y. Okay. Let's discuss one more question. Y is equals to e raised to power x sine inverse x upon x square. Let's say this is the question. Fine. Now here it is a mixture of product rule as well as quotient rule. So first dy by dx is equals to, so x to the power 4. Now e raised to power x sine inverse x. To differentiate this, I should apply product rule. So differentiation of e raised to power x is e raised to power x into sine inverse x as it is, plus e raised to power x into 1 upon root over 1 minus x square into x square. Fine. Now minus in between, the differentiation of x square is 2x into e raised to power x sine inverse x. So I have applied product rule over here, and in whole we have applied quotient rule. Okay. So today we have discussed the introduction part, that is first principle method, and we have discussed use of standard formulas. Do revise all the formulas so that we are going to in the next methods we are going to discuss that will be helpful. Okay. So next method we are going to discuss is chain rule, then logarithmic, differentiation that we are going to discuss in next class. Okay, thank you.